So here I'm going to show you a little do-it-yourself project that I put together for a mere $14. I kind of like to look at this as a variable current limiter, and what it is it's a device that you plug in between the appliance you're powering and the wall outlet that it's receiving power from. And by making use of a simple rotary dimmer, you can adjust the amount of current going to that particular device that you're powering. So let's get started with this. The first one needs some basic items from your local hardware store, and I've got 3 of them pictured here, and we'll talk about them each in the following bits. The first we'll need is just a basic 28-cent nail-on electrical receptacle box, and we won't need the nails for this later, so we're going to go ahead and take those nails out later in the video, but this will hold the dimmer switch. Next we need our power cord for both input and output, and I've got a 6-foot 16-gauge outdoor extension cord, so this will provide both the male and female plug ends to provide power from the wall and to the device. And then we have our item that will vary the current, and here I've got a 600-watt standard rotary dimmer, which can of course vary the current and then also act as an on-off switch for the device. And we're going to need some tools. So I've got a large set of wire cutters, a good automatic wire stripper, and also a slotted and Phillips head screwdrivers. So first thing we need to do is measure out our extension cord to 3 feet for each end and then cut it in half. So this will provide both the input and output feeds to the dimmer inside the box. And again, since we're not going to be nailing the box to anything, you can just go ahead and take the nails out of it. The box does not need those. Then what we need to do is take the 2 ends of the extension cord that we cut and feed them inside the box. And we also need to use something to cut back the insulation and then strip the wires on each ends. Now we need to set the dimmer up to the wires. And the wires are already color-coded for the neutral and ground connections that you need to make. It also comes with a pack of wire nuts. You'll need 1 more wire nut since you need 1 for the hot lead. And then it also comes with a set of screws used to mount the dimmer switch to the electrical box. And you'll see all those connections here in the coming bit. Now here we've got all the electrical connections done. We've got black to black, white to white, and the green or gray depending on what color your ground wire is connected to that. Again, it only comes with 3 wire nuts, so make sure you keep an extra for that hot wire. Now we've got the dimmer switch installed inside the electrical box and fastened down with the included screws, and we pulled all the slack through. So now what we need to do is work on installing some kind of cover plate, which I show here. I had an extra cover plate laying around, so you might want to search for a standard wall switch cover plate to cover it up. And basically we've completed the variable current limiter. So afterwards here I'm going to show 2 videos I did with it in operation on both a vacuum cleaner and on a lamp with both an incandescent and fluorescent bulb. So let's get to those. So I've got the current limiter plugged in to an outlet here, and then the other end I've connected it to a vacuum cleaner. Here we go and show how it works. The cleaner's already on. This is already at its lowest setting, so it's not going to power on until I start adding some current. Now another interesting showing of this is what it does with a lamp like this that has both an incandescent and a compact fluorescent bulb in it. The bottom section here has a incandescent bulb. The upper part has a compact fluorescent bulb in there. This has an interesting way of showing the efficiency current-wise of the CFL compared with an incandescent. So I'm going to turn this all the way to its max setting and turn the lamp on. You can see both the top and bottom are lit. Now I'm going to get this out of the way here and start adjusting it downward. As you can see, the bottom lamp is getting dimmer, but the CFL is not losing its brightness. Not until about here is where it starts falling off. And see, now it's at the point where it's flickering now because there's too little current to really keep it going. I turn it back some. And the CFL comes back on, yet the incandescent in the bottom is still really dim. Back. And there's really no change in luminescence brightening it up here. It's just the bottom incandescent one is the one that's changing. So it kind of illustrates an interesting difference between the incandescent and CFLs in their current consumption. That's a little interesting thing to illustrate using this device.